I hope you all are doing well. This side Priya Bhatia, and in this particular video we are starting our new topic, which is with respect to the ensemble techniques that we have in machine learning. Specifically talking about ensemble techniques, we have broadened two categories, bagging and boosting, and in this video we will focus on the bagging part. Okay. Now, before watching this video, the major prerequisite is that you already have a clear-cut idea about the above videos which I have uploaded in machine learning playlist. Means you should have a clear-cut idea about how linear regression works, how logistic works, how decision trees works, right? We have seen that there are few techniques that we have in machine learning which are helpful to solve the classification task. For example, logistic regression we have talked about. Then there are few techniques which are designed to solve a regression task. For example, linear regression we have talked about. Then there are few techniques which are designed to solve both the aspects, classification as well as regression, where we have talked about decision trees, right? So today we will see that why there is a need of bagging technique, which comes under the category of ensemble technique, how it works, and at the end of the video I will show you the practical demonstration also. So please stay tuned until the very end of the video so that you will be able to get the clear-cut idea behind this bagging technique. Then only you will be able to understand the upcoming videos where I will talk about random forest, which is one of the bagging technique in machine learning. So let's get started. So whenever bagging term came into picture in machine learning, first of all, you have to understand it's a part of ensemble techniques. As the name suggests, ensemble, meaning we are trying to accumulate multiple machine learning models in a way. That's what we are doing here in ensemble techniques. So here what is happening is we divide into two parts. One thing is bagging that we will talk about in today's session. And the second thing is something which we have is boosting. Don't worry, we will talk about boosting as well in the upcoming videos. But as of now, just focus on the concept of this bagging part. That what is happening here in the concept of bagging, okay? Now what is happening? Suppose I will be having maybe 1000 records, okay? I will be having maybe 1000 records and let's say 5 features are there. F1, F2, F3, F4 and F5. Okay. Let's say that in these 5 features that I have, okay, these 5 features that I have, maybe F5 is the outcome that I really want to predict. Now this outcome can be 0 or it can be 1. So I'm talking about here the classification part. Okay. Now what is happening? In a way, we will be having 4 input features and fifth feature is the target one. And in total, what I am saying is I will be having 1000 number of records. In a way, I will be having 1000 number of records. Now, what I will do in this bagging technique, let's try to understand. What I will do is I'll try to create bags of these samples that I have with replacement. And that's what we need to understand. What is the meaning of that? What is the meaning of that? So what I will do here is, I'll try to take the samples randomly out of the given 1000 records that I have. For example, I have picked up the second sample, okay, and I have pushed it here. Now what is happening is that you can again pick up that same sample, that same record. That's why I'm saying with replacement, you are trying to pick up the records in the first ball which I have designed. Now here also you will be having again 1000 records, but these records are maybe repetitive. It might be the case that you will be having only 800 unique records and 200 of them are repetitive, right? 200 of them are, obviously it indicates that 200 of them are duplicate or repetitive, right? That's why I'm saying we are trying to, or internally the model is trying to take the samples randomly. Now, why is this randomization came into picture? Why we are doing so? That's a bigger question, right? Okay, we are doing so, or our model internally is doing so. What's the need behind that? See, what is happening here is that what we will do is we will try to repeat the same task for maybe, let's say, I'll try to create model M1, model M2, model M3, model M4 by doing the similar task. Now, every model might have unique records. Maybe here 700 of them are unique and 300 of them are duplicate. Then similarly for M3 and M4. Randomization is coming into picture. Now what I will do is, I'll try to train these separate models simultaneously. Suppose I will be having 4 models, and what I'm doing here, maybe I'm applying a decision tree algorithm in all these 4 models that I have. Now what will happen? Every model is capable of giving me the predictions that whether the outcome is 0 or 1. Do you agree with me? What I'm saying is, every model will be able to give me the prediction that whether the outcome should be 0 or 1. Now, what will happen here? When I'm increasing this randomization, the problem of normal decision tree was, now this topic, only those people will be able to understand who followed me in the previous session. That's why in the initial part of the intro video, I have already talked about, that's the prerequisite. So in decision tree, the major issue is the overfitting. Now, what is the meaning of overfitting? The simple meaning of overfitting is that we will be having low bias, means at the time of the training, when I'm training my model, the model's accuracy is very great. But at the time of testing, the variance is very high, means accuracy drops down very instantly. That's the major issue. Now, what will happen? When I'm increasing this randomization and I will be having multiple models to be trained on the same algorithm, it can be decision tree, it can be logistic regression, it can be linear regression, anything you can think of, right? But what I'm saying is, why it is called ensemble? The simple reason is that here, not a single model is working. Here, multiple models are working simultaneously. Now, you may ask me one question that, Priya, okay, you told me that multiple models will work. Then how the accuracy or how the prediction will be, happen? So what will happen is, once you train your model on the training set, at the time of testing, every model will give you the prediction. Suppose M1 will say that the prediction is 0, M2 will say that the prediction is 0, M3 will say that the prediction is maybe 0, and then M4 is saying that the prediction should be 1. The outcome should be 1. So what will happen is, here the concept of something called as majority voting came into picture, which will say that whatever the majority says, whatever the majority will say, that will be the final answer. Means 0 will be the final answer in this particular case. Now, again, you can ask me one more question. Okay, here though you have taken the classification task. What if I will take the regression task? Does this bagging algorithm will not work there? No, it will work. So this bagging technique will work for both the tasks. Even this ensemble technique, whether it be bagging or boosting, will work for both. For the regression as well as for the classification part, right? So what will happen in regression then, if I will follow the same approach? You know that in regression, we will be having continuous values. Let's say, I'm not predicting an outcome here, but I'm trying to predict a price of a house. So that's the continuous value. So what will happen? I think everyone understands at that point of time, what we will do is, we will try to make the average, to make a final call, to make a final prediction, right? Because there we will be having the continuous values, not the discrete numbers like 0 or 1. We don't have the classes there. So that's the main idea behind this bagging technique, which says that what we will do is, we will try to take separate models, and then they will be having the records from the original dataset that we have, and they will take the records randomly with replacement, so that what it will do is, this randomization will help my model to, reduce the overfitting mainly, okay? Reduce the overfitting by a reduction of the variance part. That's the major reason behind this algorithm, okay? That's the major need. Now, in bagging itself, we will be having a very famous technique that I'll talk about in the upcoming session, that is the random forest, okay? I'm not talking about here itself, I'll talk about it in the next session, but I believe that now you will be able to understand that what this bagging is composed of, what is the meaning of bags here, and how it is working internally to give a better result, better accuracy, I would say, and how it is, more powerful than the normal, I would say, single decision tree, or maybe any other model as well. It's not compulsory that you have to use decision tree in this bagging technique. Okay, perfect. Let's move ahead. So when you will implement this, you will see that in sklearn, I'll show you the implementation now. We will be having both the things, bagging classifier and bagging regressor. So I can show you this thing. So here we will be having, I hope you can see my screen, bagging regressor, and then we will be having something called as bagging classifier. So this is the one which is for the bagging classifier. Now here you can see a bagging classifier is an ensemble meta estimator that fits base classifier. Now this base classifier is something which model you want to take up, maybe decision tree, maybe linear regression, anything you can take up, each on random subset of the original data set, and then aggregate their individual predictions. Either we will do the maximum voting or we will do the averaging to form a final prediction. And that's what I said. I highly recommend everyone to just go to the documentation and read it out once as well. Now here, if you will observe, we will be having few important parameters. For example, number of estimators is one of them. Means how many number of decision trees or how many number of models you are really looking for in that bagging model. Similarly, another important feature is something that we have is the, just give me a second. Another important feature that I want to talk about here is maximum features. Like how many number of features you are really looking for. How many number of features that you are really looking for to be trained on, right? So what we will do is, we will try to here take two important parameters. One is the estimator. Estimator is that what is the base estimator that you're really looking for. Maybe decision tree, maybe any other model. Then second is the number of estimators, means how many number of decision trees. If suppose I'll take the number of the estimator as decision tree. So how many number of decision trees you have? Second thing. Third thing is maximum features. This particular part I'll talk about in the later part of the random forest video. Okay. But as of now, just focus on these two parts. Okay. Now, the full form of this bagging, if someone will ask you, it's something which is bootstrap aggregation. Okay. So here, bootstrap aggregation. Here we are trying to aggregate our model. Okay. So this is something which you can take it off. And now, as I told you, in sklearn, we have the libraries for both the tasks, whether it be regression, whether it be classification, depending upon what kind of problem we are solving, we will try to use that kind of a model. I hope it makes sense to everyone. So now I believe you will be able to understand the intuition behind this bagging technique, and it's the correct time that we should try to approach towards the implementation part. So what I can do here is, let me try to open up the Jupyter notebook or maybe Google Colab file. We can take it up. Okay. So what I can do here is, I'll try to import first of all whatever important packages I am really looking for. Okay. So what I can do is, I can say import pandas as PD to read the file, import numpy as np. From sklearn, I'll import a model underscore selection, and then from sklearn dot tree, suppose I'll take the base classifier as the decision tree here. Okay, so I will import the decision tree classifier here. You can take any of them. Okay, it's not compulsory. I'm again and again saying this thing. Now, apart from this, what we need to do is, because we are using classification task here, so we need to call, it's there in ensemble because it's an ensemble technique. We need to import something called as bagging classifier as well. Okay. Now I hope you will be able to understand what is the meaning of this bagging classifier. I think there must be any spelling mistake. Yeah, bagging classifier. I think now it should work. Yes. So now what we can do is, we can read the file. I have already mentioned the location. And then what we can do is, you can look upon this file. I think you already aware about this data set because I have used in previous videos as well. It's a diabetic data set where I will be having, if I just show you the shape of this data, you will be able to see that we will be having 9 features where the last feature is the outcome value. If you will observe here, this outcome is something which is representing the final value, which is either the person is diabetic or not. So it means in a way we will be having 8 features, and on the basis of those 8 features, either the person will be diabetic or he or she will not be diabetic. Perfect. So now what we're supposed to do here is, I'm just skipping the EDA part. I already did the EDA in the above videos. You can just check it out of the same data I believe I have taken. Now what I will do is I'll directly split my data into training and testing, and will show you that how you can apply this bagging classifier. Or if you have some regressor problem, then how you can apply the bagging regressor. So what you can do here is, first of all, let's try to do the splitting part, model underscore selection. What we can do is we can import something called as train test split. And after that, what we can do is we can say this is X train, we can say this is X test, we can say this is Y train and Y test. And here this is equals to train test split. I hope now you all are aware about these things. Okay, we didn't specify what is X and Y. I'll specify that as well in the above part. Test sizes, let's take it as maybe 0.33. And after that, let's take the random state maybe as 8. I have already defined all these parameters and what's the meaning of that. I'm not repeating those things here. So X will be equals to data dot drop, and here my columns is equal to obviously the outcome value that I have, and the axis is equals to 1, right? Because we are deleting column wise, and Y is equals to data of outcome, right? So now I have defined what is X to me and what is Y to me, like independent and the dependent feature that I have. And then I'll call the train test split. Once this is done, now I need to define what is the base classifier which I'm using here, okay? I'm taking it as decision tree classifier as of now, okay? And I'll define how many number of trees I'll pick it up. As of now, I am just randomly writing this number as 500, but there is some technique called as hyperparameter tuning, which I am planning to take it up in the upcoming live sessions. And I'll show you that how you can optimize these hyperparameters. But let's not talk about this as of now. Let's take it 500 as of now. So what will happen is, it will try to take M1, M2, M3 until M500. That's the literal meaning of this. And every model is having a decision tree classifier. Every model is trained on this decision tree classifier on the subset of that original data that you have, okay? Now what will happen is, you will define the model, which is equals to, you will say bagging classifier. And here what you will do is, you will define that parameter, which 2 parameters I have talked about. The very first parameter is the estimator, right? Which I have defined it as a base classifier in my case. Makes sense? Another thing which is important for me is, as of now, is number of estimators, which I am defining it as number of trees here, okay? And then maybe I can define the random state, which as of now I'm taking it as 8, okay? I'm not taking as of now all other features, max features. I'll take it as default. I'll talk about all these features also in the upcoming session, where I'll talk about the random forest. But as of now, let's consider that these 2 features are important, and we have specifically defined those 2 features, parameters, sorry, not features, parameters. Okay, now what we can do, we can just, let's first of all get the model. Now what I want is, I want to fit this model on my train data. So what I'll do is, I'll say X train, and then I'll say what is the value of Y train, right? Once this is done, let it done. Fitting is done. So we will be having a bagging classifier now. What we can do is, if you want, you can just predict the values by saying model.predict, and here you can mention X test. So what you will be able to get is the predictions of your data. Either it will be 0 or 1 on the testing set. If you will say model.score on the X test and the Y test, you will be able to get the score as well pretty easily. Okay, so let it run. So here what we're getting is a score without doing any EDA, without doing any pre-processing, without removing any sort of outliers. I know this particular uh, data set is having a lot many outliers also in insulin, because I remember in EDA I have shown you that how is this happening. So uh, I have skipped those parts, but all I think you will be able to get an idea that how basically we will be able to implement that bagging classifier thing. Now because we will be having the outcome value which is either 0 or 1, if I'll give you some use case where instead of outcome, I will provide you some continuous values, means it's a regression kind of a problem, I believe you will be able to implement that. Instead of using this bagging classifier, at that point of time, maybe you will use a bagging regressor. And instead of using a base classifier as decision tree classifier, you will use decision tree regressor, right? Or maybe any other model as well, any other algorithm as well. So this is the main idea behind the, I would say, bagging algorithms that we have. Now in the upcoming video, I will talk about something called as random forest. Very amazing algorithm. We'll talk about in very detail how it works, what's the mathematical intuition behind that. Now the prerequisite to understand the upcoming video is this only. So I hope that you enjoyed this video. You will be able to understand the concept behind the bagging technique. And I'll see you all very soon in the upcoming video where we will now talk about random forest. Stay tuned. Bye-bye. Happy learning to all. Keep learning, keep exploring.